Ever pondered why a profound understanding of various machining processes is vital? Well, because these processes are the backbone of countless industries and they shape the world around us. So, let's delve deeper into this fascinating world and unravel the mysteries of machining processes step by step. The first stop on our journey is die sinking EDM, also known as spark eroding. This process is all about using electrical discharges to cut intricate shapes into metal. A series of rapid-fire sparks fly between the metal and the electrode, gradually sculpting the metal into the desired shape. It's like lightning carving a masterpiece out of thunder. Next, we have wire-cut EDM, a sibling to die sinking EDM. Instead of an electrode, a thin wire carries the electrical charge, cutting through the metal as it moves. This process allows for precise cuts, even in complex designs. Think of it as a high-tech puppeteer, pulling the strings to create a piece of art. Now, let's turn our attention to ultrasonic machining, a process that uses a tool vibrating at ultrasonic frequencies to remove material from a workpiece. It's a bit like a microscopic jackhammer, pounding away at the surface to create the perfect shape. Our journey continues with plasma arc machining, a process that uses a high-velocity jet of ionized gas to melt and displace material. Picture a bolt of lightning, harnessed and focused to cut through metal like a hot knife through butter. Next, we explore the world of chemical and electrochemical machining. In these processes, chemical reactions or electrical energy are used to remove material. It's like using a magic potion to dissolve away unwanted parts, leaving behind a perfectly formed piece. High-energy beam machining is next on our list, with two key types, laser beam machining and electron-beam machining. In these processes, a high-energy beam is used to melt or vaporize material. It's like using a focused ray of sunlight to burn a hole through a leaf, but on a much larger scale. Then, we have water jet and abrasive jet machining. Both processes use a high-pressure stream of fluid, either alone or with abrasive particles, to cut through materials. Imagine a stream of water so powerful it can slice through steel as easily as a knife through paper. Lastly, we'll look at advanced joining processes and 3D printing. Joining processes like welding and brazing allow separate pieces to become one, while 3D printing builds objects layer by layer from a digital model. It's like assembling a puzzle or crafting a sculpture, creating something new and unique from individual pieces. In summary, each machining process offers a unique approach to shaping and manipulating materials. From the precise sparks of EDM to the high-energy beams of LBM and EBM, from the chemical magic of electrochemical machining to the power of water and abrasive jets, and the innovation of advanced joining and 3D printing. Each process plays a crucial role in manufacturing and engineering. So the next time you marvel at a complex piece of machinery, remember the intricate dance of machining processes that brought it to life.